let me know. Thanks. Okay, so the last thing that we did, we talked about how the degree of my polynomial is going to match the number of possible zeros, okay? And please understand, just because my degree is 2 doesn't mean I have to have, this is in 4-1. We didn't finish 4-1. We got just a couple of questions left in 4-1, I believe, right? So I'm at the end of 4-1. So I remember I took that x-axis and I was moving it all over the place to show you how many zeros we could have. I might not have 2 zeros. Maybe that x-axis was way down below my parabola where it never touched the x-axis, but I'll never have more than 2 zeros, okay? So we would say if the degree is 2, then I have at most 2 zeros, or if the degree is 5, at most I will have 5 zeros. So just keep that in mind. I don't necessarily have to have that many, but I can have up to that many. All right, so let's go down. Actually, I think this is the last question, right? Number 4? Yeah. And I've already told you this. You had one like this on your test where I make you review stuff we've done in chapter 1, chapter 2, and chapter 3. I love these kinds of questions, okay? Because it makes you remember stuff from previous chapters. So, so this part A, that's new. It says find the following round to the nearest hundredths when necessary, graph below once finished. All right, so this part A is new. What is the degree of this polynomial? 5. Why is that? Degree is? Highest power. Yep. All right, part B, this is also new. What's the maximum number of turning points? Now, Dylan, you're out because you just answered that. So what's the maximum number of turning points? Say it again, Blake. 4. Why is it 4, Blake? Very good. It's always going to be my degree minus 1. Okay. All right. So Blake's out too. Again, part C, a new concept for chapter 4. What's my maximum number of zeros? Now, before you answer that question, what's another word for zeros? Solutions, X-intercepts, solve roots. Okay, so I could ask this question in any of those ways. I could say, what's the maximum number of roots? What's the maximum number of zeros? What's the maximum number of solutions? What's the maximum number of X-intercepts? All of those are the same question. But if you don't realize that they all mean the same thing, and you only memorize one of them, you might get stuck if I ask one of the other ones. Okay, so what is my maximum number of zeros, roots, solutions, X-intercepts? 5, because it's the same as the degree. Okay, part D, end behavior. So I'm being asked to draw a little end behavior picture. Now you remember, I had 4 choices, okay? So look up here. Choice number 1, both sides were up. Choice number 2, both sides were down. Choice number 3, 1 up, 1 down, overall downhill. Choice number 4, 1 up, 1 down, overall uphill. Okay, so what am I looking at? There's 2 things I have to look at to answer this question. Okay, so the degree, we already know 5.
Coefficient.
And what's the other thing I need to look at?
Leading coefficient.
Good, it's that leading coefficient. Okay, so you already told me that my degree was what? 5, which is what kind of a number? It's an odd number. Okay, so immediately I know I've got either a 1 up or a 1 down, right? It's got to be one of those 2. And then what's my leading coefficient? It's positive. Okay, so do I want the 1 up, 1 down? That's an overall downhill, or do I want the 1 up, 1 down? That's an overall uphill. I want it to be uphill. So then my little end behavior picture would look something like this. Now, when I do this, a lot of students are like, Ms. Roberts, why do you have the little dashes in the middle? Is that what you were going to ask, Ellen? Okay, I can read your mind. Actually, I can't. It's just that so many students every single semester ask the same question. I know what to predict. So why do I put the little dashes in the middle? It's because I can have a whole bunch of wiggles in the middle, turning points if we're being mathy geeky. Okay, but I can have a whole bunch of wiggles in the middle. So I'm not picturing here the wiggles in the middle. I'm only picturing what's happening on the ends. Okay, so that's why I put a dashed line in there. And usually on my lab, it's a multiple choice. They give you the 4 pictures and you have to pick one. Okay, so if you were taking a paper test, then yes, I would ask that you put a little dashed line in there, but you won't be.
Those pictures on the actual thing have all the little turning points in the middle.
Not all of them. Not all of them. So some might, but not all of them. Okay. All right, so then part E. All right, so this is a review question. What's my domain? What's my range? You know what? All I really need is my little end behavior figure to answer this. I don't even need to graph it yet to come up with this. Okay? So when I look at that little ends behavior picture, what is my domain? What values of X am I using from left to right? All real numbers. So my domain is from negative infinity to positive infinity. All right, somebody else, when I'm looking at my range, what's my range when I look at my little end behavior picture? Somebody who hasn't answered yet.
All real numbers.
Yeah, all real numbers again, because we go all the way from the bottom to the top. You know, in the first week of school, we talked about domain and range. And one of the things I told you guys is I said, get really, 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 really comfortable with domain and range because we are going to talk about it often. Can you agree with me that we've covered domain and range almost every single day of the semester so far? And that's not going to change a whole lot between now and the end of the semester. Okay, so get comfortable. If you're not by now, you better get comfortable. All right, Y-intercept. Again, also something that this is a review. Okay, so this isn't new for chapter 4. Tell me this. What do all, okay, so here's my Y-axis. What do all Y-intercepts have in common? Next value is 0. Okay, well if my X is 0, go back up to your equation. Look at your equation. Put in 0 for all the X's. When you put in a 0 for all the X's in the equation, Justin, what do you end up with? A negative 4. So then by the way, if I asked you to draw a Y-intercept, what kind of figure would you draw? A point. If you're going to draw a point, what kind of answer are you going to give me? It's got to be a coordinate. It's got to be a coordinate. So we've got the coordinate 0 because I plugged in 0 for all my X's. Negative 4 because that's the value that came out when I plugged in 0 for all my X's. Okay. All right, now the rest of it I have to graph, and the rest of it is review. It was on your last test. Okay, so take out your calculator. Now the thing about this equation, I've got an X to the 5th power. What's different about this is I've never done one this large. The largest that I've ever done would have been a squared, a degree of 2, okay? So that's what's different about this. So let's go ahead and you'll want to use, oh, my batteries are low. You'll want to use the caret for the 5th power, the 4th power, and probably the 3rd power, okay? So go to your Y equals. And you'll type in X to the 5th, X caret 5, etc. Let's all start with the same screen. So go to Zoom 6. Zoom 6, remember that's your standard window from -10 to 10 and from -10 to 10. So let's all just be looking at the same screen. Show your screen to somebody close to you, and let's make sure that we're all looking at the same screen once you've graphed it. Zoomers, you guys, if you can hold it up to the camera, you two can check each other's. Okay. We all have the same picture? Yeah, and somebody who's close to Blake, look back at his as well. And Mary Alice, has anybody checked with Abigail?
Can you see it?
No.
Is that hard on the screen?
Yeah, mine don't light up like hers.
Brianna, move it a little closer to the screen.
I think they're the same.
Yeah, I think so. Same. Same. November, you're still working on it? Go back to your y equals. You have times. That should be plus. And between x squared and x should be x squared minus x. Okay, so what we're looking at then, so what we're looking at is we need to find our x-intercepts. So look at your screen. How many x-intercepts do we need to find? We need to find 3. That means that our process, we have to go through the whole process 3 times, starting all over again to find each one. So but I'm gonna basically, this is roughly what you're looking at, and yep, it's dead for sure. So I'm not gonna be able to do anything on the calculator. So you're looking at something like this. Let's all look for the same x-intercept first so that we're all on the same page here. So we're gonna look for this one first. Okay, now do you remember from the last test? How do you do that? Okay, so go to second trace, go to zeros. Second trace, go to zeros. And what does your calculator ask you? Yeah, it asks you for a left bound. And the way that I told you, now if you're comfortable with this, you don't have to listen at this moment. But the way that I talked you through this is I said, get as close as you possibly can to that x-intercept, and then just go like 2 clicks to the left, using the left arrow. We're gonna talk about that. Okay, and push enter, and now your calculator is asking you for a right bound. Okay, so you do the same thing, get as close as you can, go 1 or 2 clicks to the right. You don't want to guess, so push enter. Okay, now, first thing is, an x-intercept is a coordinate, so I'm writing this as a coordinate. Okay, now, like I said, my calculator it's totally dead right now. It's totally blank, so I can't do this with you. But what is the x-intercept? What's the x value? Now make sure you follow the directions. Okay, so what's the x value of this first x-intercept? All right, I have to trust Sierra, so I'm going to ask the rest of you, do you agree with Sierra? And did she round properly?
Yes.
Yeah, because how did the directions tell you to round? To the nearest hundredths. And what was it actually? Negative 2.517. So that's going to be it's going to raise it to a 2. So we're okay with that. What's your y value say? Is your y, I know Dylan's looks funky. Does anybody else's y value look funky? Good. So I asked this last chapter and nobody ran into it, so I figured I would just wait to have this discussion when we all ran into it. Is your hand up or you just?
Not stretching.
No, it's okay, stretch away. I just wanted to make sure I wasn't ignoring your question. And so what does it say exactly? I know it says something e to the negative 12.
Negative 4.9. This is mine.
Okay, yeah, it says something e to the negative something. Am I right? Okay, did I get it? How about you guys on Zoom? You guys agreeing with that?
Yeah.
Okay. So what that means, that is code for, you ready for this? This is hard. It's code for 0. Why does it do that? So it's actually, do you guys know what scientific notation means?
Yeah.
Basically what it is, let me get to a place that doesn't matter. You said, I'm gonna go with Dylan's. He said negative 4.59 something e to the negative 12. What, or e negative 12. What that means is times 10 to the negative 12. Okay, whatever. And so what we're doing with that then, times 10 to the negative 12 says that you're gonna take your decimal place and you're gonna move it to the left 12 places. So literally this is negative 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 4, 5, 9. I would say this is pretty stinking close to 0. Okay, so why does your calculator do that? I haven't the foggiest clue. I don't know, but just so that you know, it's code for 0. Okay, so when you run into any kind of an e to a negative or e with a negative number after that, then that's code for 0. So we're gonna put 0 in here. Okay, that takes care of our first x-intercept. Let's go find our second x-intercept. So back to second trace, go to zeros. When it asks you for the left bound, get as close as you can and go 1 or 2 clicks to the left. Use your left arrow. Then push enter. We're gonna ask you for the right bound, get as close as you can, go 1 or 2 clicks to the right. Push enter. You don't want to guess. Push enter. All right, somebody on Zoom, what did you guys get for the middle x-intercept?
Negative 1, 0.
Oh, was it pretty? You guys agree with
Yeah.
her? Oh, nice. I didn't even have to do any rounding. Okay, and now I've got one more. Okay, so go back through the whole entire thing all over again. We want to get close to this one, that one on the right. Second trace zeros. You are. Did you go to second trace? 0. Where are you blinking right now? Get as close as you can to the x-intercept. Okay, that's fine. You are on the left. You go 1 more click to the left. Push enter. Get as close as you can again. Yeah. Okay, but you have, there you go. No, go back. Now you're on the right side. Push enter. You don't want to guess, so push enter. And then you have coordinate.
Miss Roberts,
Is
mine says error.
that probably means that when you did the left bound and the right bound, you probably had them both on the left or both on the right. You have to have your x-intercept has to be between the button you choose or the spot you choose for the left and the spot you choose for the right.
Okay, I think I got it.
Okay, now did you get a coordinate, Brianna?
I got 0.
What'd you get for the x part?
Negative 1.6. Wait, no, I'm doing the middle one. I was trying to find the y value for the middle one, and it said
gotcha.
error. I didn't even know you were on, you're ahead of me.
Sorry. Yeah, we're doing the third one.
My bad, I'm sorry.
Okay.
I got 1.14. Yeah.
What you got? 1.14?
Yeah.
2.14, comma 0. Okay. Now, I'm told that I'm supposed to be graphing because my directions, notice they said graph on the axes below once you're finished. Okay. So I've got some points that I've been working with. Let's go and put what I know so far on the graph. So I had a y-intercept at 0, -4. So let's go ahead and put our y-intercept on there. And then I had x-intercepts -2.5 basically. So there's -2.5, -1, and then a little bit more than 1. So there's my 3 x-intercepts that are now on my graph. Still not ready to graph my picture yet. And I'm not even ready to get part H, the intervals of increasing and decreasing. I need part I, the extrema, before I can find my intervals of increasing and decreasing. So let's go back to my little picture. How many extrema do I have? There's 2. What is extrema is the umbrella word for what? Maxes and mins. Okay, so I have 2 extrema. Are they both the same kind of extrema? No, one is a max and one's a min. Let's go look for the maximum first. So this is where I'm going to focus on this guy right here. Okay, Brianna, are you with us?
I don't know what I'm doing wrong.
Okay, let's leave that alone for right now, Brianna. Let's work on finding the maximum, and then if you need, you and I can meet on a Zoom meeting.
Okay.
And I'll walk you through it step by step, okay? All right, so let's go look for the maximum then. Okay? Where do you go in your calculator to look for the maximum? Oh, back to the same menu. So push second trace. And inside of second trace, where do you go? Which is maximum. Oh, that's a shocker. Okay, so go to maximum. And what does your calculator ask you? Left bound. Okay, so once again, get your cursor as close to the maximum as you can, and then go a couple of clicks to the left. Once you get there, push enter. Brianna, you with us?
I think so.
Good. Brianna, does your calculator ask you a new question now?
No, it just gives me the X and Y.
Brianna, did you go to second trace?
And put in maximum.
Uh-huh.
And then it asks left and right bound and then guess.
Oh, you're already there. Okay, so I was just still at the left bound part.
Oh.
Okay. So, all right, so now you're at the right bound. Your calculator's asking you for the right bounds. Go back to the maximum, go a couple clicks to the right, push enter. You don't want to guess. Okay, and now you should have a coordinate. So again, I need help here because I couldn't do this along with you. So where is my maximum? Brianna, did you get that? Negative 2.02, 10.01?
I got negative 2.127.
All right, I have to depend on you guys. Is it the negative 2.02 or the negative 2. What she said? Okay, it's the 2.02. We'll take a look at it, Brianna. What'd you get for your Y value, Brianna?
9.6.
Okay, it's a little off. Okay, we'll take a look. You know what I'm guessing? I'm guessing, Brianna, that maybe you actually typed in your original equation. You might have like switched a plus sign for a minus sign. It might be something that simple because it's really close. So, all right, let's go back through. Let's do the same thing for the minimum. November, you're doing this one. Okay, so go to second trace. Only this time don't choose maximum, choose minimum. When it asks you for the left bounds, so on our picture, this is the guy we're looking for. So get close to the minimum and go 1 or 2 clicks to the left. Push enter. Same thing for the right. Don't want to guess. All right. Do you have a coordinate for us, November?
Giving me the X value 0.3 and then negative 4.24.
You guys in agreement?
Yeah, you're rounding up. Oh, okay, sorry. So 0.41 and then negative 4.24.
Are you guys in agreement with her? Okay. All right, so that's 2 more points and then I can go put on my graph. All right, so going to my graph, let's see, -2, I'm gonna change colors on this, -2, 10, basically. Really close to that. And then 0.41, -4 plus a little more. Okay, so now let's take the points that we have on the graph, let's take the overall shape that's in our screen, and let's just connect the dots. Okay, so matches our end behavior. How many turning points are there? 2 turning points. How many did we expect to have up to? 4. We could have had as many as 4. That was just creepy.
I'm sorry, I was waiting for a good stopping point.
There are no good stopping parts in math point 10.
I just did rulers. But I didn't want to like in the middle of you. Here's the asymptote. Sorry.
Sorry. All right, any questions about that then?
See, good stopping point.
Yeah.
Any questions?
All right, so Brianna, do we need to meet on Zoom?
I got the last one right. I don't know what I did wrong.
Okay, all right. Well, maybe we can just try to take a look at it real quick later on, okay? Or maybe try it again on your own when you're not on the spotlight, you know, because that automatically makes you make mistakes. So try it on your own. Do you have the right answers written down?
Yes, ma'am.
Okay, try it on your own. See if you can get it when you do it again.
Okay.
Let me know. Okay, so let's head into 4.2. All right, so we have 2 methods for division. Let's go ahead and just get this out of the way while we're here. So when you have your next test in 2 weeks, you'll have at least a question where you have to show me your work on dividing, okay? Do you remember how the last test, I had 4 questions in a row. One of them was solved by the completing the square, solved by the square root method, solved by the zero product property, solved by the quadratic formula. Okay, you remember those 4? And I looked at your work. If you did not use the zero product property on the problem that I asked you to use zero product property, I didn't give you credit. If you use the quadratic formula on the question for completing the square, I didn't give you credit because you didn't use what I asked you to use. And it's going to be the same thing with this. So if you have, don't show me the work by the long division method, I won't give you the credit, okay? There are multiple ways to do this, but there are reasons behind what I asked. So, so just understand that if it says use long division, then I'm gonna expect you to use long division, I'm gonna be looking at your work, okay? It doesn't even have to say, show me your work. because it says to use something specific. So I'm gonna look to see that you use that specific thing. All right, so I walked you through a third grade problem from your former days. For some of us, that was a lot longer ago than others. And then I made it match. A polynomial. Now, the deal here is, just so that you know, and I did point this out, is that my lab does this in the very last assignments. So I'm starting 4-2 out with long division. My lab in your assignment, it ends with long division. Okay, so if you think there isn't a long division problem, there is. It's the very last assignment. Okay, so things are a little bit in a different order. So let's go straight into example number 2. And let's do what the video said to do. Okay, so you're probably, because this is on a new page, you're probably going to want to have the how-to from the first page. Okay, because I'm going to keep asking you, what's step 1, what's step 2, what's step 3, etc. So have that available so that you can answer the question. Okay, all right, what's step 1? Wait. All right, divide, but what am I going to divide? And you can't just point, because I don't know what you're pointing at. Okay, so you're going to divide the, how did I word it in the video, Blake? It should be written on your notes. Divide. Oh, uh-oh, did you just get caught? Yeah. November, what does it say? Divide what? Exactly. Divide the leading term by the leading term. So the leading term on the inside is the 3x to the 4th. The leading term on the outside is going to be the x squared. So we're going to divide 3x to the 4th divided by x squared. Now, when you divide your numbers, 3 divided by 1 is 3. And when you divide your letters, think about what you can cancel. What's x to the 4th divided by x squared? X squared. Okay, so when you divide, you're going to end up with 3x squared. Some teachers are really picky about where you put that on the top line. Like some people say, if it's an x squared, you got to put it over top of the x squared. I'm not that picky because I don't feel like it's that big of a deal. Question?
I was just going to say the way that I learned it is just, I mean, it's pretty similar, but instead of like dividing it like that, it's just seeing what you can multiply that leading term on the outside by to get the leading term on the inside. Absolutely.
You're rewording it, but you're saying the exact same thing. Mm-hmm. Yeah, we're saying the same thing. Okay, so what's the next step then? Abigail, what's the next step? Okay, so I got to take the guy that I just found, the 3x squared on top, and what am I multiplying by, Abigail?
You're multiplying all the way through.
Good job. I got to multiply every term on the outside. So the first thing I'll do is I'm going to take 3x squared times x squared, and I get what? Now this is important that you line up the like terms because we're going to be adding or subtracting in a minute. And then I also have to take the 3x squared and multiply by the middle term. So somebody else, what is 3x squared times a positive x? Positive 3x to the 3rd power, yes. Okay, and then I have to take my 3x squared and I got to multiply it by my last term. So that, what is, somebody who hasn't answered yet, a 3x squared times a negative 1? Negative, can you say that again? I just didn't catch it all. Yeah, negative 3x squared. I heard the x squared part, I just didn't hear the 3. All right, so negative 3x squared. Okay, so then what's the next step in the how-to? Yes, subtract, and we got to subtract every single term, right? Okay, now I believe that the way I showed you this on the video is I might have even used a different color. And since I'm subtracting every single term, you have to change the sign of every single term. So when I subtract the first term, it's going to be a negative. When I subtract the second term, it's going to be a negative. And when I subtract the 3rd term, it's going to turn into a positive. I think that's how I showed it to you on the video. Okay, so now let's combine our like terms. My first set of terms gives me what? 0. Good, I'm not going to write it down. My second set of terms gives me negative x cubed, right? Because 2 minus 3 is a negative 1. And then my third set of terms gives me positive 2x squared. Okay, so then what was the next step in the list, Mary Alice? Not yet. Before that. Yeah, I got to bring down my next term. Okay. So now I'm going to go back to the beginning of the list. And the first thing in the list said divide leading term by leading term. So once again, here's my new leading term now, divided by my old leading term. I'm always going to be dividing by the same term. Okay. And so this is going to be a negative x cubed divided by a positive x squared. And when you divide, what do you end up with there? Negative x. Okay, so my first step, division, that's done. What's the second step? Multiply. All right, so remember you're multiplying and you got to multiply all three terms. So what is going to be my negative x times my x squared? And what are we forgetting? It's a negative. Good. So it's a negative x cubed. And then we've got a negative x times a positive x, which gives me. And then lastly, we have a negative x times a negative 1, which gives me a positive x. What's the next step in the list? Subtract. So I'm going to change colors again. And since I'm subtracting every single term down there, every single term has to change signs. So combine your first two terms and what do you get? Okay, not going to write that down. Somebody else, combine your second two terms. What do you get? 3x squared. And then another person, what happens when you combine your last two terms? Okay, a positive 3x. What's next in the list? Bring down. Okay, the last step. Repeat. Do it again. Okay, so here we go. Divide, leading term divided by leading term. So here's, I've got a new leading term divided by the old leading term. And what do I get? Let's see, let me write it down. So that's going to be a 3x squared divided by an x squared. So what does that give you? And what am I going to write down? Plus 3, because that's a positive 3. Next step, multiply. So we've got 3 times x squared. Okay. Somebody else, take 3 and multiply it by the middle term. And somebody else, take 3 and multiply it by the last term. Okay. Now I need to subtract. And in order to subtract, I'm going to change all my signs. Oh, what happens? Well, okay, so everything zeroes each other out. So I get, what is that guy called in 3rd grade? I get a remainder of 0. Do you remember in 3rd grade, like every time you got a remainder of 0, like you did this little happy dance, like, woohoo, I must have done it right. Do you remember that? Yeah. By the way, just because we get a remainder of 0 doesn't always mean we just did it right because there's a remainder of 0. But leading into something I'm going to be saying in a little bit, when I get a remainder of 0, it does mean, the way we worded that in the 3rd grade, it means, oh, it goes in evenly. You remember that phrase? Okay, it goes in evenly. It works perfectly. Now that we're in Math 110 and we're so much like better than we were in 3rd grade, we wouldn't say it goes in evenly. We would say, ooh, when I multiply, I have 2 nice, pretty factors. Okay, in 3rd grade, we would have been like, ma. Okay, but that's what's happening now. I have 2 nice, pretty factors when I'm multiplying. Okay, so that's long division. All right, synthetic division. We walked through that with you. I gave you a little how-to in the yellow sticky note. I also gave you something I found on Pinterest. That's not mine, but it was cute. So, all right. Example 3. Okay, now I have no clue as to what this My Lab note is, so I'm about to unhide what I have there, but I don't know what it says underneath there. because I wrote these notes a long time ago and I forget what it says. So let's discover the hidden box. Okay. So what happens is that this is the way that my lab sets it up. Mine is going to look a little different, but you can set it up the way I do it, or you can set it up the way my lab does it. I don't really care. Okay. So this is how my lab would set this synthetic division up. I write it a little bit differently, but either way is okay. All right. So first thing is what are we looking for? When I'm about to set up my synthetic division? I'm making a list of what? All of my coefficients. Okay, so look at your polynomial. And what are your coefficients in order? 1. Now, what's a really big deal that you have to pay attention to, that you have to be on the lookout for? Missing terms. Missing terms. Now, when you look at this polynomial, you'll notice what's the degree? 4, and I have a term for every single power after that. So I have a 4th power, I have a 3rd power, a 2nd power, a 1st power, and a no power. So I'm not missing any terms, so I don't have to have any placeholders here. I'm good. Okay, but if there's a missing term, it's got to have the placeholder of 0, which is what Sierra was talking about a little bit ago with that video. Okay, she's going to send it to me so I can take a look. All right, and then I told you to set up a box on the left. And according to your synthetic division how-to, what always goes in the box? Whatever x equals. Whatever x equals. All right, so what do I mean by that? Take a look at what I'm dividing by. This is what I'm dividing by. It doesn't say x equals, it says x plus. But if you did a little tiny mini solving problem and you got an x equals, what would you get? X equals -4. That's what's going in the box. Always put x equals in the box.
But how would you do that in the way that my math says it?
It would be the same. It's the same.
No, I'm just trying to figure out how you would like actually do it that way. Like after you get the -4, like how you would write this stuff out of the version.
I would have my equation bar down there.
Okay, so
It's exactly the same. They just use a division bar. And I didn't want anybody to get confused by that. Okay, so we have this process of multiply, add, multiply, add, multiply, add, multiply, add until you run out of numbers. But before I start the process of multiply, add, what's the one thing I gotta do first? And what's that called? What's the generic word for that? Not just a coefficient. Yeah, it's my leading coefficient that I got to bring down. There's no math involved in that. It's purely a copy. Okay. All right. So now I'm going to start my multiply add. So go ahead and multiply by the box. And what do you get? Okay. So that's going to go up here. Okay. And then you're going to add and you're going to get 0. Okay. So there's my first round of multiply add. Do it again. Multiply by the box. And these are what you're looking at here. Multiply by the box, you're going to get 0. Add 2. Do it again. Multiply the 2 by the box. Add 1, because a 9 plus a -8 is a 1. Multiply by the box. -4. Add 0. Okay. Now, after you're finished with this, you're always going to put a bar between the last 2 numbers. Now, let's go back to the directions. I was told to find the quotient when dividing. Okay. So the last number, this guy, according to the video, is always going to be your what? Remainder. And what's this guy? Your quotient. Now, it doesn't look quite right though because all the variables are gone. We have to put the variables back in. All right, so what is the last guy called? The constant. And the one before it has a what? Or an x to the first, right? I don't have to write to the first. And the one before that. And so that my quotient is x cubed plus 2x plus 1. What's my remainder? 0. And our third grade little self wants to do a happy dance. Okay, because we like a remainder of 0.
The numbers on top don't matter. Like the on the top of the bar, that doesn't have anything to do with the quotient. Like,
Mm-mm.
Okay.
They help me get my quotient, but they're not in my answer. Just like November when I was doing long division, when I get my answer, none of these numbers matter anymore, right? So same concept. All right, let's look at this remainder theorem. To find P of K, just find the remainder when you put K in the box. Okay, now hang on a second.
So let me just solve it.
What do you mean by normally? Actually, don't say anything. I'm coming back to your question. Because when you look at number 4, before today, what would you normally do? You would plug and chug, right? You would do 2 times 2 times 2 times 2 minus 3 times 2 times 2 minus 5 times 2 plus 4, right? That's what you would do before today. And what I'm saying as of today is that there's a shortcut to that. Now, plug and chug is not difficult, but if there's something easier I can do, why shouldn't I? I can use synthetic division, but now we're going to call it synthetic substitution. The work is the same. So when I'm setting up a synthetic question, what would I set up for my polynomial? What's the first thing I make a list of? All of my coefficients. And what are my coefficients? What are we on the lookout for? Were there any missing terms? Did you remember to look for them? That's a big deal. Make sure you look for missing terms. Okay? What always goes in the box? Whatever x equals. Now, what is it that I would have been plugging in? What am I making my x equal to? 2. So that's what goes in the box. Whatever x equals always goes in the box. Okay, so now we're going to start our process here. Bring down your leading coefficient. Okay, multiply. Oh boy. I thought I was asking an easy question.
22.
Multiply. 4. Add.
1.
Multiply. Add. Multiply. Add. Put your bar in there. Now, according to our theorem, if I wanted to find P of 2 in this case, all I need to do is find the remainder. So, P of 2 equals what? -2. Now, here's what I want to point out to you guys. In the last 2 questions, let me turn the screen so I can show both of them. The last 2 questions had totally different instructions. The work was exactly the same, and they had totally different answers. Okay? Totally different instructions, totally different answers, but the work in between was identical. So if you're asked to find find a quotient, or if you're asked to divide, your answer is going to be a new polynomial. Your answer is going to be a whole entire quotient. But if you're just asked to plug in a number using synthetic substitution, your answer is only going to be a number. Okay, it won't be a whole polynomial because I'm not dividing, I'm just substituting. Now, Dylan, did that answer the question that you asked a minute ago?
How would you type that in?
Yeah, because it's probably going, you know how it always kind of prefaces and it'll say maybe like P of 2 equals box? You'll just have to pay attention to what it says, but yeah. Okay. Is the given number a 0? In other words, does it go in evenly? Does it go in evenly? Okay, so when this says, is the given, by the way, what are some other words for 0? Solution, solve, X-intercept, roots. Is that it? I think that's it. Okay, so I mean, I could say this, the same set of directions. I could say, is the given number a solution? Is the given number an X-intercept? Okay. So let's find out. So what I want you to do is I want you to work through synthetic substitution. Don't say anything. You work through the synthetic substitution on example number 5 and tell whether or not this is a 0. Is the given number a 0? Show it to somebody close by once you have it. So you might want to put a yes or a no there so that the person around you can.
What two terms are being added after you? Once you multiply the
The number by the box,
what do you add together?
the two numbers that are written one right over the other.
So 2 plus 1?
Well, I don't know because I haven't done the work yet.
Oh.
But up here, it's these. Did you miss the how-to on the video, November?
I watched it this morning and I was gonna ask about it. I want to see you like do it in real time because it was a little confusing.
Gotcha. And that's normal. I'm okay with that, just so you know. I'm okay with that. But go watch it again and it'll make like 10 times more sense now that we've done it together. Okay, and it'll solidify it in your mind. All right, so do you guys have an answer for me? Okay, is it a 0? Yes or no? No? Okay, Zoomers, yes or no?
I thought it was yes. But
Okay, what do you think, Brianna? You're muted.
I'm not finished yet.
Oh, okay. Okay, so let's go ahead. What are my coefficients? Why is there a 0? Because there's a missing x squared, and then, okay? What always goes in the box?
X
No,
equals
-2 does not always go in the box. What always go in? Say, I heard it again. Say it again.
X equals.
Yeah, the x equals, and in this case, it is x equals -2. All right, so pull down your leading coefficient. All right, no math there, just copy. Multiply, all right, November, I want you doing this one, okay? Multiply by the box. So take the 1 and multiply by the box. What do you get? Okay, now add these two together. Okay, now multiply by the box. Add. Multiply the box. Good, add. Mm-mm. Mm-mm. Which is? Yeah. Negative 13. Put your bar in. Okay. So is the given number, negative 2, is it a 0? Is it a solution? Is it an x-intercept? No. Why not? Oh, that's a bad reason though, Dylan, because are you saying that if I had ended up with negative 2 down on the bottom, since negative 2 equals negative 2, it would have been a 0? No. So can you reword it? Your brain is thinking correctly, you're just speaking incorrectly. The remainder isn't 0. The remainder isn't 0. So just to give you a visual picture of this, if I were graphing this, I would be graphing the coordinate negative 2, negative 13. That's the coordinate I would be graphing, because if my x value is negative 2, my y value is negative 13. But if it's going to be an x-intercept, what do all x-intercepts have in common with each other? A y value of 0. So if it's going to be a solution or an x-intercept or a root or a 0, it needs to be something comma 0. Okay, so that I can draw it on the x-axis. All right, go do the same thing for number 6. Same question.
So we don't have to add a 0 because there's no like plus 3 or whatever without the x.
So I'm actually going to discuss that, Rebecca, and I'm not going to say yes or no.
Okay.
Good question. All right, now, Rebecca asked a great question. She said, do we have to put the 0 on the ends? And the answer to that is, yes, you do. This time, it works in your favor if you accidentally forgot it. Because this time, when I tack on a 0, when I go ahead and multiply, I'm going to get 0 and I'm going to get 0. Because the last two numbers are the same, I would still get the same answer. But that's not always going to work like that. So this time it would have worked in your favor, but that's not always going to be the case. Okay? So we would say that yes, negative 4 is a 0 for this polynomial.
We know when to switch the x terms, because for k we didn't switch from a positive to a negative, but these two we did. Or we didn't.
What are you talking about?
So like when we went to example 3, the leading term, we made it from a positive 4 to a negative 4.
Okay, so that's not the leading term. Okay, so let's this is the leading term, so those didn't change. Okay, you're talking about what's in the box? Well, always goes in the box, no matter what. Whatever x equals. Okay, so here, I don't know what x equals. I have to find it. What would x equal if this was a mini equation and I solved it?
Oh, yes, it's just sign for negative.
So it would be x plus 4 equals 0. I would subtract 4 on both sides and it would be x equals negative 4, right?
Oh.
So it's whatever x equals. I didn't know at that time, I had to find it. But down on here, I do know what x equals, so I don't have to find it. They gave it to me.
Okay.
So, but it's always, the rule is always whatever x equals goes in the box. Okay? All right, one or more zeros are given.
Is this some random page that just printed out extra? I think I heard this. Someone else in the house that printed that.
So did anybody else get a funky random page about MMC? Gotcha. She might have needed that, Dylan. Yeah, I don't see that on anybody else's notes. Okay, so one or more zeros are given. And by the way, guys, if I give you a zero, I'm not going to lie about it. It really is a zero. Okay, so there's a couple of steps on this one. If you are given a zero, step number one, prove it. Prove it. I'm not going to be telling you a lie, but you still have to prove it. Okay, so what's the zero that I've been handed for example number 7? 3 is the zero, but that I've been handed. I need to go prove it. All right, so whatever x equals goes in the box, so that's going to be a 3 in the box. My coefficients, 1, 2, -11, -12. Did I have any missing terms? All right, Justin, how about you do this one? I haven't heard from you today. Okay, what am I going to do first? Good, and then? Yep. Yep. Wait, aren't you supposed to be adding? Okay. By the way, that's a really common mistake, Justin. I'm glad you made that mistake because now we're all going to have a little red flag to make sure that we add correctly. Keep going. Good. Okay. Now I have a question for you. Are we surprised that the remainder was 0? Why not, Devin? It said it was a 0, and I just got finished telling you I'm not going to lie to you. So, Justin, if you had made that little mistake, but we hadn't caught it, you would have ended up with another number as the remainder. And here's what your brain is going to do, guys. You're going to go, wait a second. She told us she wasn't going to lie to us about this being a 0. I must have done something wrong in my math because I didn't get 0 there. I got to get 0 here. And that would be your clue to go back and rework the question, okay? So if you don't get a 0, you did something wrong. Do it again, okay? This isn't a surprise that we got a 0 here. All right, so step number 1, if you're told what a 0 is, go prove it. Step number 2, by the way, let's go and look at the directions. Find all the other zeros. So how about let's start making a list. All right. I know that one of my zeros is x equals 3 because they told us and we just proved it. Okay. And then lastly, I'm supposed to be factoring. I'll get to that in a minute. Can you look at this equation, this polynomial? How many zeros should I be looking for?
3.
Why 3?
The degree is 3, the highest.
Because the degree is 3. Remember that your degree is the same as the amount of zeros you might have. Okay? All right, so what we're going to do, can I take you back for a minute? Let's take a rabbit trail. Take a rabbit trail. Do you remember the factor tree? Ah, like that was a long time ago, right? So let's do a factor tree for 24. Okay? Remember, a factor tree is where you want to factor this number down as far as it will go. You want to break it into all of its factors. So what was a pair of numbers that you could use for 24? 12 and 2. What's another pair of numbers you could use? 6 and 4. What's another pair of numbers you could use? 3 and 8. And all of those are okay. Okay? I'm gonna choose 6 and 4. Why? Because I feel like it and I'm the teacher, so I get to. Okay. Am I done? No. So then what do I do? Yeah, so you need to break down the 6 and you need to break down the 4. Wait. Did you ever go back to the 24 and find another pair of factors? Okay, 6 and 4. Great, I'm factoring. So now let's go do 12 and 2. No, you don't go back to the 24. You break down the little guys, right? Okay, so let's break down the little guy of 6 and you get 2 times 3. And you break down the little guy of 4 and you get. So basically what you're doing is you're factoring the factors, right? Because the first thing you did was there's 2 factors of 24. And then you decided to factor the factor, right? You always are working with the little guys. Okay, now, so how does this play into what we're doing? Come back up here. My quotient is a factor. So we're going to factor the factor. Now, can we write our quotient properly, please? What's our quotient? Now, since I'm trying to factor, since I'm trying to find solutions, you set it equals 0 because that's what you do when you're trying to find solutions. You set your polynomial equal to 0. Hey, wait a second. We had a question like this on the test. And you were supposed to solve using the 0 product property. So let's do that. So 0 product property says that we factor. What's our first piece on each factor?
X plus 5.
Okay, so sorry, I asked that poorly. So our firsts are the x and the x. What are the numbers that you're going to use for the 4? 1 and 4. And what kind of signs will you use to get a positive 5x in the middle? Plus on both. Oh, but this isn't done. Yes, we have factored, but we haven't solved. So what was the solving that we had to do in our last test? Yeah, I have 2 little mini equations. Now you're in Math 110. You don't have to show this next step. You can if you want to. But you have x plus 1 equals 0 or x plus 4 equals 0, little mini equations. So that x equals or x equals somebody else, -4. Hey, guess what? There's my other 2 solutions, my other 2 zeros. Let's put them in the list. X equals -1, x equals -4. Hey, did I have the 3 that I expected I was gonna have? I sure did. Okay, so let's look at the directions again. 1 or more zeros are given. Yeah, we proved it. Find all the others. I did that, and I did that by factoring the factor. Okay? So I found all my zeros. Then the next statement says, factor into linear factors. Okay. So let's make another side of the chart. Let's take each of our zeros and change each of our zeros into a factor. And you go, what are you talking about, Ms. Roberts? You've already done that. Within the last 2 minutes you did that. I want you to take a look. Do you see how here you had factors and you turned your factors into zeros, right? We'll go backwards. Now take your zeros and turn your zeros into factors. So just go backwards. So the 0x equals 3. What does that look like as a factor? X minus 3. The 0x equals -1. What does that look like as a factor? X plus 1. And the 0 that is x equals -4, what's the factor? x plus 4. Don't you dare think you're finished, because you're not. Because I was supposed to write p of x in factored form. Okay, so let's write p of x equals. Factors are things that we multiply together. Again, you did this within the last couple of minutes. Look right here. You took the standard form and turned it into a product of factors. That's what we want to do. Okay, but now instead of just having 2 factors, I have 3 factors. So, what's my first factor? Times, somebody else for the second one. Times x plus 4. Now, there is one more thing that you need to check. This is a big deal. Can you go back to the p of x? What was the leading coefficient on the original p of x? It was 1.
1.
It was 1. What's the leading coefficient on this factored version of p of x? 1. As long as they match, you don't have to do anything. Okay, if they don't match, we got to do something, and I'll tell you what you need to do when I get there. But as long as they match, you don't have to do anything, but you do have to check. You do have to check. Okay? All right. So number 8, I have worked out for you. I'm guessing I did that on a video. No? Okay, so why do I have it worked out there then? All right, so I only have 2 minutes though. I can't work it out. So tell you what. Today, you sure I didn't work that out on a video?
This second sheet right here, and then the video ended.
Okay.
I went all the way to 4.3 because I got.
Okay, all right, yeah. We need to work out number 8. I don't have time to do it today, but we need to, and I'm gonna forget this by Thursday, so can you remind me? Okay, I need to work out number 8 with you. I would like you to try it on your own. Try working out number 8. You probably are gonna get stuck on something though, okay? So try it, get as far as you can, and I'll do that one at the beginning if you'll remind me, otherwise I'll forget. Bye guys, have a good day. So Brianna, try those, the maxes, the mins, and the zeros again, and text me and tell me whether you were able to get the same answers as us, and we'll set up a Zoom meeting if we can, okay? If you can't get them.
Okay, so I mean, really all you do is get closest as you can and then go 2 clicks to the left.
When it's asking for the left bound, and then get as close as you can again and go two clicks to the right when it's asking for the right bounds.
Got you. Okay.
When it asks you for a guess, ignore that and just push enter. Does that
I'll
make
let you
sense?
know. I got.
Yeah.
I don't know when I did the first couple times. I got the last one right.
Okay, all right. So then you're doing something right. And there are links to videos that I gave that walk you through exactly how to do it, and they can show you the screen while you're doing it too. So you can try it there.
Okay, thank you, ma'am.
All right, see you, Brianna.